So, hello everybody. Yeah, my name is Udo Heidel. I'm working for PTV now for 33 years, and I started in 1991. And the most part of my time, I did I built travel demand models, in Visum, of course.
Udo, maybe a little bit closer to the microphone.
Okay.
Sorry.
So I built travel demand models in Visum. I built in Germany a lot, in France, with Frederick in this time, at the beginning, so 20 years ago, and also in Dubai, in the Middle East, in Qatar, in Dubai. In Dubai, I'm still working in a project. And I learned that it's a very time-consuming and it's also expensive undertaking to build really a good, well-calibrated travel demand model. This is something, it's expensive and time-consuming. And over time, we saw that one part of the building process is to collect the data, integrate the data, and then start calibration. And what has changed since then is that the data are more and more public available. They are standardized. So we can now produce the model by a software, a part of the model, especially maybe not the full model, but we're working on the full model. But a part of the model we can automate and build automatically. So. And this I want to show you today, what we can already do, and how you can buy a Model2Go and what you get. But first of all, I want to, this is my structure of the presentation. I have one slide about Visum, because this is also important to understand what Visum is exactly, and then Model2Go, which of course delivers or creates model for Visum. And then I have some use cases and evaluation examples. And finally, I have a big example, I think, the Sustainable Urban Master Plans. These are from the European Union. They are specified for specific producing a master plan, and want to give some thoughts how Model2Go and Visum can be used for SUMs. So, Visum. I don't know if somebody of you know what Visum means. Visum is, of course, it's an abbreviation of something, and it's from Germany. The authors of Visum, the first programmers, they thought about what is the name for the software. And they said it's Verkehr in Städten Umlegung, which means transport in cities assignment. So you already recognize the use case, what they have thought on. I have a network, I have a matrix, and I do an assignment. This is what Visum should do. This was for almost 40 years ago. But meanwhile, Visum has developed to a multifunctional GIS platform for transportation planning, I would say. I would call it in this way. So Visum can do thousands of different use cases. Of course, travel demand models is maybe the most sophisticated use case, but it's one of several. So, and also when you buy Visum, a license, and you install it on your computer and you start it, it looks more or less like that. There is, meanwhile, a background map, but this background map is only for orientation. You cannot do anything with that. You see, it's empty. So it's more or less Visum, and I know a lot of people who think Visum is a transport model. No, Visum is the toolbox to build the transport models and to work to do transport planning. It's a tool. So what you need for a model, you need a road network, a digitized road network, and we can get it today from, well, you will see, I will mention it later, from HERE maps or from TomTom maps or from OpenStreetMap. You need also, maybe if you want to do a multi-model study, you need the public transport network, and then you need this public transport network comes with a timetable, and then you can already start to do some analysis, what Fana showed for lines. You can do also in Visum. This is a isochrone for a mobility hub in Munich. So, and you can do also, I think the core functionality of Visum is founding shortest path from A to B, and for every zone, and this is and you can do that in Visum. Of course, this is a key functionality. These are only some examples. So this is what is required at the minimum. And here's also the travel time from these 2 points. So then I mentioned already the idea of Model2Go. So meanwhile, we have a Model2Go technology in Visum. This technology is web-based, and this technology is generating routable multi-modal maps and georeference socioeconomic data. We call it also in our world, we call it transport supply model. Yes, this can be generated in an automatic way. The Model2Go technology collects or integrates data from either TomTom or here or OpenStreetMap or in future also from Overture Maps, which is a new initiative from Microsoft and Amazon. They want to do, you can say, a competition against Google Maps. They have joined together with TomTom to create a map, and we will, of course, use their maps for creation of models. And we use for public transport, we use, there's a server called Transitland where you can find a lot of GDFS files and national access points. I will mention it also later. So we use also machine learning methods for the data generation. And data, what we integrate are digital roadmaps, points of interest, public transport supply data, stop location, line routes, timetable, and census data. So a lot of different data we integrate. We use, of course, also country-specific data. For example, census data from Italy is only valid in Italy, not in somewhere else on the planet. Then you can also give us, if you have, for example, your own zone system and you want to have a disaggregation of your zone system, which is already there, you can give us your zone system, and then we talk about the disaggregation, how the zone should be disaggregated, and then we can do it in an automatic way. We integrate also data from TomTom, both FCD and also I will also mention it later, OD data from TomTom. So the time for provision of such a supply model is 2 to 3 days, and from the order to delivery around a week. We do a lot of checks, and we have if for example the public transport GDF files are complete, if there's any line is missing, and so on. So we try to give our best to deliver you a very high quality model. And this replaces, I have from my experience, I know this replaces about 2 to 3 months of manual work if you do that with the old traditional methods. And we learned from that we can also produce, can do a mass production of models, and so we produce, for example, for 80 German cities and 25 French departments models, and from these models we generate data what we sell via PTV Access, what Lorenzo has mentioned and explained. This is a new data product, so we can use this technology to generate data what we sell. And in the future, I mentioned it also already, we will add travel demand modeling to this on top on this supply models, and this will be also using AI calibration technology. So this is what is Model2Go, and the Model2Go works as follows. So I did it for the preparation for this for Napoli. First you have to specify a model area. You can do that by simply draw an area, or you can give us a predefined area like the city area or the regional area or a wider one, and then we use this area for the production. You have to give us the number of zones you want to have. So if you want to have 1,000 or 2,000 zones, we can create independently an arbitrary number of zones. Or you give us your zone system and we use the zone system, or we, as I said, already disaggregated. So also our GDFS files, what you have maybe from your client has maybe the best GDFS file what you can get, and it's not published, and you can give us to us, then we integrate this file. So then this will be put into the Model2Go process, and then after some hours, the Visum version file comes out, drops out of the Model2Go production system. We can check it. We will have a automatic generated test protocol and check that. And so this is also the public transport, the GDFS file, what I found 2 days ago on Transitland. So, but this we can do everywhere on this planet. This is Atlanta, Cape Town, Paris, any arbitrary city. Although, of course, not every city has a GDFS file or every public transport operator. So, only a short look at the different networks or the private transport network. So we will generate a link categorization. You have different link categories like highways, primary roads, secondary roads, access roads, and so on. The free flow speeds are taken from the map provider, like here or TomTom. They have a quite good speed information because this is the data you use for the navigation, and this must be good. Yes. And then we calculate also link capacities from the number of lanes of the different links, and based on highway capacity manual, we use the formulas from there, and then we equip the model also with elevation data that we can calculate maybe assignment and use it for the assignment for electric vehicles or bicycle assignment and so on. So the public transport GDFS files, they are, as I said, often open. They are publicly available. There's one reason in Europe that the EU has already, I think in 2016, has released delegated regulation that this data should be open in Europe, that any app producer can use this data for the needs of the app. And there's other regulations at the end. The member states have started to implement a national access point. There's one in Germany, in Italy there's also one, and on these national access points you find the latest GDFS files. And they are provided sometimes in GDFS and also in NETEX they are sometimes provided. There is also converters from NETEX to GDFS, what you can use to get a GDFS file. Yes, so this is what I did produce for 2 days ago, I think. So the Model2Go supplies also equipped with socio-economic or socio-demographic data, so from the census data, so you can quickly produce a population density map. And we have what we will release in a few months, I think, is a workplace generator. So we use AI functionality to calculate spatial distributed workplaces, because in Germany at least, I don't know in Italy's situation, in Germany this is a very weak point in every demand model, because workplace data, spatially distributed workplace data are not known. They are known on the community level, but not known for every zone. And this, we have developed AI-based algorithm which works on building types, which tries to categorize building types according commercial use building or residential use building or mixed use building. And based on that, we generate number of workplaces. And then we have a lot of data from the points of interest regarding shopping facilities, leisure facilities, schools and whatever, and this is also in the Model2Go, this data. Then we have an add-on. Of course, we know that a supply model can only serve some specific use cases, but if it comes to demand, we need something. So far, we don't have a synthetic demand model, but integrated Model2Go, but we work on that. But I think also empirical collected origin destination data. We heard the presentation about mobile phone data, but we have so far another kind of data. It's the data from TomTom. TomTom collects from their embedded devices, what they have embedded in the different cars, OD data, and we can send them any arbitrary, produced zone system, we can send to TomTom on their web portal, Move portal, and then they will give us their demand back. So, and it's not, the zone system must not be defined in advance. We can send any of them, yes. So, but we get only car demand back, and TomTom or DIDA, of course, these are only a sample of the true ground truth demand. It's only between 10 and 15, 20% of the real demand. But any survey is also a sample, you know, it's something which is normal in transport planning. And I think, so customers can use this sample OD matrix and project it via any matrix estimation method which is implemented in Visum. Okay, this is what is Model2Go demand. And yeah, use cases. What you can do out of the box with Model2Go supply is to do accessibility analysis, similarly what Vanas has showed you, but this is can be done in a multi-model way. So you can add new supply, and then you see how the accessibility has changed. You can do this in a scenario analysis, and this is a out-of-the-box use case. For example, what I did here for Munich, Munich is the distance from the main station and how many people live within 15 minutes public transport travel time from home to the main station. This is in Munich about, I have it here, no? Oh, it's not here. It's too small. 430,000, and within 30 minutes it's more than 1 million. So that every Munich citizen can come to the airport, to the station in 30 minutes. And this I already showed. This is for this mobility hub. And I did also something in a quick way. I don't know if the numbers are right for Napoli. So the second use case, what you can serve out of the box is if you want to do a traffic study regarding car traffic, you have the Model2Go supply model, you have the TomTom matrix, you can calibrate the TomTom matrix, you can assign it, and you can calculate scenarios, you can block a street, you can insert a new road and see what happens if this new road is inserted. Then the assignment model will show you, based on the new network, what will be the impact of this new road to the route choice. Yes, not to the demand, because there's no induced demand. Yes, and the
yeah. Super sorry to interrupt, because it's a very interesting tool, but we really have to go a little bit quick, because then we're really
4 slides.
Okay, because then we're really
So the last big use case is travel demand model, what I already mentioned, and yes, but you can explain that Model2Go is not delivering a full travel demand model in the moment, but of course it's a base, and you have to you can start. You don't have to invest this first 3 months to collecting data. You can start with the Model2Go, and then you can already go into the demand modeling. This is also an important feature. Yes, then I skip a little bit the sustainable mobility plans, only a few comments to that. You know that the European Union triggers and push cities in Europe to do sustainable urban mobility plans, and it's in the guidelines. It's not clearly said that cities have to implement or have to use a travel demand model for it. But I think, because if you look at the scope of a sustainable urban mobility plan, that in the big cities it's absolutely necessary to build a travel demand model, and then to do things like, this is a proposed structure of a SUMP. There's a point number 3, analyze mobility situation, and point 4, build and jointly access scenarios, and that you have to do with a travel demand model, and then select measures, packages with stakeholders, and have an assessment system. This is something you need a travel demand model for. Yes, and I have had some projects together with the European Union, and in the future they will be keen to get key performance indicators from the different cities in Europe in a regular way. And these KPIs are about accessibility, about congestion, about greenhouse gas emissions, accidents and model share and air pollution, and all this can be quite good served by a travel demand model. And so that I think for me it's became a little bit mandatory and necessary for cities to maintain a travel demand model in future. Okay, thank you very much.